What's up guys, Shawnthebro here, and today we're going to be going over how we can use raycasts to determine which objects we are looking at, and that will allow us to interact with objects by looking at them. So we have two different methods of interaction that you'll commonly see within games. We have the one where if you're within a certain distance from an item, such as our weapons currently, I can interact with it regardless if I'm looking at it or not. Games such as Halo use this method, so if I'm walking and something's on the ground below me, I can pick it up without ever looking at it. However, you may also have this option, where if you look at things, then you're able to interact with them. This is better when there's more loot or more potential to pick things up, because you may have to be very specific about what it is you're hovering over and want to pick up. So this would be something like your battle royales like Apex Legends or Fortnite. You can see here when I look at this object, then text prints to the screen because it is saying we are able to interact with this and then the name of the object. But when I look away from it, I have no object that I'm able to interact with here, so there's nothing printing. Basically today we're just going to set up the entire system for performing the raycast and actually determining which object we are able to interact with. We will go over specific interaction logic for something like doors, or picking up weapons and items later in the series. But in this episode, we're just setting up the system as a whole, and then from there it's actually very easy to expand. We can just basically override the logic for each item to determine what that item should do when interacted with her. I want to give a huge shout out and thank you to my YouTube membership and Patreon members and supporters. Thank you guys for everything you've done. You guys are awesome, and I really appreciate that you are as excited about these series as I am. I'm so incredibly grateful to have you guys. It is great to see how we are all working on our games and how the progress is coming along, so thank you so much. With that said, we can go ahead and get started. Before we get into this specific episode, if you are interested in catching up to any of the other episodes in the series, I'll link the playlist right here in the top right corner, so you can check out everything we've done to get to this point in the tutorial. We have a really long way to go, but we've come a really long way from the beginning as well. If you don't care about that, but you do care about your different methods of interaction, I'll show you how we set up our first interaction method, which is the overlap with items to be able to equip them and pick them up, such as these weapons here. So today's episode is going to be a large mix of code and blueprints. Let's look at something in the base character blueprint first, and then we're going to go into the code to actually add the logic. If we go into our base character BP, and this is our main character, or the character that we're playing as, we had a character mesh and a first-person camera. Now you might see that I have a second character mesh and a second first-person camera. Don't worry, by the end of this we're only going to have one, but I want to actually make my mesh and my camera in the code as opposed to making it within the blueprint in this case, because I want a reference to it that I can use to do things from. So for example, if I want to draw a raycast to see what we are interacting with or what we are looking at, I could do that in the blueprint. However, I actually want to do it in the code for many reasons. One of them being the performance of raycast in code is very good, very efficient. Then I'm going to need a reference to these objects in my code. So I could have a reference variable that gets set when this blueprint loads and we're good to go, or I could spawn it directly from the code. I think it'll be beneficial to spawn it directly from the code, so I'm going to go over that today. So you may have a mesh and a camera already in here if you've been following the series, but we are going to make a new one in the code, and I'm not going to have the one in the blueprint anymore. I'm going to delete it by the end of this episode. So let's start with that specific logic, and I'll show you how I set that up. If we go into the code, specifically our base character.h, for me is the FPS tutorial character.h, you can scroll down to wherever it is your variables are. Now, for me, at the very bottom of my character.h, I had two functions. I had getMesh1p and getFirstPersonCamera component. These functions actually came from the template, the first-person shooter template, within Unreal. I did not make them, but I had previously commented them out. I actually do not need these functions here. I had commented them out, like I said, and we went over commenting them out, and I was like, we could use them later in the future, and it's true, we could use it. Maybe we will want it in the future, but I don't need it now, so to avoid confusion, I'm actually going to get rid of both of these functions. I'm going to get rid of the get mesh 1p and the get first person camera component. And I'm just going to place these here instead. So to get rid of some of that ugly commented out logic that we weren't using, I've gone ahead and done this right here. So these two variables that I made, the character mesh and the first person camera component, are completely new. I did not have them in the past. So you can just follow along and do what I've done here. So in this case, we had uProperty, visible anywhere, blueprint read only, category equals character, meta equals allow private access equals true. Now, I use these uProperties because these are the defaults that come in with the mesh and the camera when making new components in code. So if you open up the template and you have a mesh here or a first person camera, this is what they're going to look like. You can actually change these to your liking. They don't have to match these descriptions. Like I said, the only reason I did is because these are the defaults that will be here for the mesh and the camera. And I wanted to stay as true to that as possible to not make this more confusing than it already is. Basically, if you made a new template and it included a mesh and a camera in the code, in the C++, this is what it would look like. So I was just mimicking that behavior. Feel free to adjust it. Just note the variable types here. They are class, and then the class of the component, such as the skeletal mesh component. So this is making a skeletal mesh, and the camera component. So this is making a camera, and they are pointers. Make sure to include the asterisk. With these two variables made, we'll be good to go into the FPS character.cpp and edit some logic to get these showing up in the blueprint already. It's actually a very simple process. Once you've made those, I'd go into the FPS character.cpp and I would scroll down to the constructor. Now, the constructor, we're going to basically add these variables to be attached to certain things. That way, the mesh and the camera are set up the same way as we have them in the blueprint. So in the blueprint, how we set it up is we have the self, and then we have a capsule component, and under the capsule component is a mesh, and the mesh has the camera under that. And so we're going to mimic that same behavior in the code by doing this logic here. So the character mesh here can create a default subobject, and this is the name of the actual object that we are creating within the blueprint. So this is our variable. This is the name of the object in the blueprint. So I had to give it a different name because I did not delete my blueprint components when making this change, and you can't have two components of the same type with the same name. So I called it character mesh, but you can call it whatever you want. The way this works is we call create default subobject, and then we give it the type of object that we're creating. We're creating a skeletal mesh component. Then we have to give it a name, and we give it the character mesh name. This text is just a conversion because technically this takes in a string, but the actual name on the component in the blueprint is text, so we want to convert it to text when we do that. After we make that object, we can determine what it should be attached to. We do currently have a get capsule component function. That's what all characters have, so this is not something that you have to write. Characters have this by default, so as long as you didn't remove it at any point, which we didn't in the series because this was already in here, and I left this in here on purpose, then we can go ahead and say the capsule is what this mesh is attached to. And that's, again, how we had it in the blueprint. The capsule has the mesh attached to it. Now we're going to do the same thing for the camera. So we are going to take our first person camera component variable, create a default subobject. This time it's going to be the camera component type. And I'm going to call it the standard camera. And then I'm going to set up its attachment to be the mesh that we made. So it's going to be under the mesh, which you can see that it is. Now, once you've done this, you're good to go. You will actually be able to load the editor, go into your blueprint, and you will see that there is the mesh and the camera here. So you'll have two meshes and two cameras now. We only need one. We can get rid of the one that we made in blueprint. You will know that you're on the one you made in code because it will have the name in parentheses, so character mesh. And if you go at the camera, it will be called standard camera in parentheses. If I look at my blueprint ones, it is just character mesh 0 and camera component. So we want to keep the code ones, but the code ones have to line up with the blueprint ones if we are to keep everything that we've done in this series consistent. Right? We don't want to lose anything by getting rid of this mesh and camera. So the code mesh and the code camera need to line up with the blueprint mesh and the blueprint camera. So what I did is I clicked on my code mesh here, and I set up my options the same way as I had them in the blueprint mesh. There's a few ways to do this. What I've done is I've gone to my blueprint version of the mesh, copied my data by right-clicking on the row here, gone to my code mesh, right-clicked on it, and pasted it in. Now I've already done this, so you can see that it didn't change for me, but I just want to make sure everything I have in here is the same. Really, all you need are the location, rotation, and scale if you changed any of those, as well as the actual skeleton and animation blueprint that you used for the blueprint mesh. So for me, I use my Ybot skeleton, whereas otherwise this will be none. So make sure you set a skeleton. When you do that, you will then be able to go to animation mode and make sure you have use animation blueprint selected. And then choose your anim class, which is the animation blueprint that works for this skeleton. So this is pretty much the same as we would have done it in the blueprint. Okay, we just created this in code, and now we're setting and assigning everything in the blueprint. But we now have a reference to these objects in the code. Now, once you do this, you actually don't have to change anything else. You can look at mine and copy it directly if you'd like. These arrows determine if something has been changed. So if I don't have an arrow here, I haven't changed it. And so you don't have to change anything else. Simple enough. We have our mesh in here, and it should be set up the same way as we had our blueprint mesh. Now the camera is the same thing. This is my blueprint camera, so I want to copy any data from here and paste it into my newly created code camera. Now there is one thing we have to do here besides location, rotation, and scale, and that is this button down here, use pawn control rotation. We did enable that on the blueprint camera, and so we want to enable that on the code camera as well. Again, I'll scroll down for you, but you can see I have changed nothing else. So it's very minor changes. We're just repositioning the camera and checking use pawn control rotation. Now, at this point, there is one difference from the blueprint one. So our parent socket here in the blueprint camera is head, and you can actually choose a socket. However, using the code camera, we can't do that. You can do it in code, but not the way we set it up. There's more that we have to do. However, I don't have my skeletons created from the code or a reference to my skeletons in the code. I just have the mesh. And so I didn't want to go down a rabbit hole of converting everything to code today, just what we need. So instead of assigning a parent socket here, because you won't be able to do it on the code camera, we do have to still attach the camera to the character's head. So to do this, I went into the construction script of the character. If you don't have a tab here, you can see it in the functions on the left-hand side. The construction script runs whenever this object is created, and so this can be done for setup, including here in the viewport. It doesn't have to be actually an actor spawned in the scene. It can be in the viewport. And so this will want to be run at all times. Now, when you come into the construction script, it will automatically have this parent called the construction script. That is good. I kept that. But I've added an additional little section here to just attach the camera to the mesh at the socket of head. So to do this, follow along. Make sure you use the new camera. And then off of that, call attach component to component. All right. Now you want to make sure the camera is the target because we're attaching the camera to our new mesh that we have here. So new camera to new mesh. Then for the socket name, type in the name of the socket that is on the blueprint camera. So parent socket on the blueprint camera is head. So when I go to my code camera, even though I can't enter the socket here, if I enter it in my construction script, we will be good. The rest you can keep default. Everything can be keep relative, and weld simulated bodies can be left as true. Edit those as necessary if you have specific uses for them, but it's fine to keep that all as default. Now, I know that was an interesting change, but it is going to really, really help us down the line. It's going to help us today, but it's going to be even more useful later, so I promise it was worth it. Once you have that, you should have it like this, where even though I have 2 meshes and 2 cameras in here, I can't tell. They're essentially acting as one because they're completely synced up. We're not quite done yet, as we do have to find all the references to this mesh and this camera and just change them out with our new camera. There's a very easy way to do this, though. If you go into your event graph, you can right-click on your mesh and find references. It will come up with a window down here in the find results that has everything that references this mesh. So what I would do is go through the list, and I'll show you where mine are. So for one, we've got one in begin play, and this is where we essentially attach the initial weapon to the mesh. That way the character spawns with a weapon. I did say that this logic was optional when we went over this episode, so feel free, if you don't have this logic in here, to just skip this, as you won't need it. However, if you have done this and you do spawn your character with a weapon, then what you're going to want to do is leave all your logic the same, but where mesh was used, use your new mesh, okay? Mesh is the old mesh. Character mesh is my new mesh. So where I use the standard mesh, I now use my character mesh variable. And I just brought this into parent. I'm going to remove the mesh reference here, and instead I'm going to put the character mesh in there. And I'm just going to space this out slightly differently. And there we go. Now we've successfully converted this to use the new mesh instead of the old mesh. You can search for this again. If you click in the text box here and hit enter, it will eliminate your other results. And now we want to go to the next one. So the next one is in event switch weapon. In switch weapon, we change which weapon is attached to the socket and what weapon is currently visible to the player. In this case, we were using our mesh variable. We want to disconnect the mesh variable and we want to use our character mesh variable. So it was connected to the parent on all of these. Instead, we want to connect character mesh to parent on all of our weapons. I actually missed the bottom one here, but don't do that. Make sure that they are all connected. Character mesh should be connected to the parent on all your attach actor to components that we set up in this function. Now you can get rid of the mesh variable there. All right, do the same process, and we have one more in detach current weapon. So detach current weapon is a function we made on the base character BP. So go to your functions, go into here, and you'll see at the very start here, what we do is we grab the mesh and get the children components of it. Then we loop through them to detach them if they're not currently the selected item. Well, they're not going to be attached to mesh anymore. They're going to be attached to character mesh. So we want to replace mesh with character mesh and use that to get the children components. Now, once you've done this, you may have some other places if you set some other things up. Just follow the same method. If you try and find references on your blueprint mesh again, it should come up with no results found. And that is good. That means we've successfully fully replaced the mesh, the blueprint mesh with the code mesh. Now, once we've done that, you can go ahead and right-click on your first-person camera, your blueprint camera, and find references to that. We should go to all these places as well. So you can see in the aim down sights, I haven't done these, we're going to do these live. I've used first-person camera, and in stop aim down sights, I've used first-person camera. Well, you know what we're going to do here then. Instead of using the first-person camera, we're going to use our first-person camera component. This is our code camera. And we're just going to replace the reference. Okay, I'm going to, again, space this out differently. I'm going to disconnect the first-person camera, the old one, the blueprint one, and delete it. Instead, we're going to use this one now. All right, and then if I hit enter again, you'll see there's only one reference left here, which is this one. And so you can guess what we're going to do by now. We're going to use our code first-person camera. We're going to pass that into the target, disconnect the old blueprint one, and remove it. Then clean it up a little bit as necessary. Something like that. Excellent. And now, if I try and search for this, you'll see that I get no results found. So we have successfully converted both the blueprint mesh and the blueprint camera to be the code mesh and the code camera. Alright, with all that done, we have to make sure that we haven't used these objects anywhere else before we delete them. We have to be extra careful. So we can right click one more time on the blueprint mesh, the one that we're trying to get rid of. Hit find references. We know that no results are found, but we can hit the binoculars to find it in all blueprints. You can see that we have no results found. Let's make sure we do the same thing with the camera since the camera is attached to it. So click on the camera, find references, and then hit the binoculars again. You'll see that I actually do use the camera in the base weapon BP. So we need to go take care of these as well. You can click on them and go to them, or you can just follow along with where I've gone. So if you go to base weapon BP, event fire weapon. In fire weapon, we determine if we're aimed down sights or not, and then we create either a ray trace or an actual projectile based off where the first person camera was looking. Now, instead of doing that off the blueprint camera, we're going to do it off the code camera. So last thing we have to do here is in each of these options, if it's projectile or hit scan, where we use the first person camera, we need to get rid of it and use the first person camera component, which is the code camera. So I drag off my base character BP, I search for first person camera, but I know camera component is the code one. So I want to use the code variable here. And then I just plug this in. Spawn projectile crosshairs has a camera component variable. And so now the code variable goes into this reference. All right, and now we have one final reference, and it's this one down below. So you do the same thing. Instead of using the blueprint camera, we use the code camera and plug that into the component reference. All right, now, once we do this, we can compile and save. We can hit enter. We know that there are no more results for either the blueprint camera or the blueprint mesh at this point. So you can safely get rid of the blueprint camera. You actually won't be able to delete the mesh because we made a new mesh, but the character.h already has a mesh. We're going to actually want two meshes on our character in the future. We're going to want one mesh is the mesh that everyone can see when they look at it, and one mesh is the mesh that the player who is controlling that character sees. This is why you may have seen things like, for example, if you take a game like Apex Legends, you'll notice that some characters may look slightly different than they do when you're controlling them as opposed to when you're looking at them. A good example of this is equipment or items that a character might have. So specifically, if you think of something like Fuse, Fuse has a mortar that he can use. That mortar can be skinned on some of his skins. So he may look as though his mortar would have that skin when you pull it out. But when you're controlling that character, he pulls out his regular mortar. This is for that very reason. There are two different meshes. So we can keep the mesh that's already here. It's okay that we can't delete it. We're going to want a second one anyway, and we're going to want that one to be created from the code, just like this is created from the character class. So you can leave it, but we want to disable it. We don't want it to be this one anymore. So we can keep this character mesh that we have here set up as the Y-bot. That's perfectly fine. This other blueprint mesh that we've now gotten rid of all the references for, we want to go ahead and we want to just take that away for now. So I'm just going to hit the arrow and get rid of this. Make sure that the skeletal mesh is none. So it's basically not active. I'm not going to deactivate it or anything like that, but I am just going to revert and make sure there is no anim class, no skeletal mesh. I'll keep the location rotation the same because most likely when we actually get into setting this up, we will want to keep the same values for those regardless, because as one turns, the other should turn. But I'm just going to leave it like this, nice and empty. And we'll leave him in here untouched. We're now using this mesh and this first person camera. Now when we come in here, we can play our game now. And you should see that pretty much nothing has changed. I know that was a lot of work to basically be in the same spot that we were in this whole time. But I promise it is worth it. We can now go forward with things like the raycast from the camera in the code for some nice performance benefits. And we can also now reference things on the mesh and the camera directly from the code, which will be very helpful later down the line. So now with that major change done, that one is incredibly important for later. I can't stress that enough. With that major change done, we can now go back into the code and set up the interaction logic that we're going to be doing from the raycast for when we look at certain items. Now, going back to FPS tutorial character.h, we need to make a variable today to determine how far our interaction distance is. We may have a pretty far distance, or we may have a pretty short distance, but whatever it is, we need to determine what that value is. So I've made a new float that I've called interact distance. Made it a U property, edit anywhere, blueprint read write, with category of interact, because I already used interact other points in the series, so we'll group all this stuff together. And we can add a comment as well. Basically, this is the distance the character can be from an object and still interact with it. We'll say the maximum. So there we go. This is how far we can be from an object and interact with it, or pick up on the ability to interact with it. And I've just called it float interaction, or interact distance. We can go back into the FPS tutorial character.cpp now, and we want to set this value. I put it to 1000. Now, 1000 doesn't really mean anything to anybody since it is a float value and it's just in the world. So you might have to play around with it, see what value you like. But it is an actual value. It's consistent. So 1000 units is maybe too far or not far enough. But give it a value for now. 1000 is a good starting point. If we go down to our tick function, for me it's at the very bottom. The only thing we had in here was regeneration of shields if we were below our maximum amount. So everything else you see in this function is what we're adding for today's episode. Essentially, we need to draw a line from the camera to the distance that we specified and determine if we've hit an object. To do that, we can use a function that exists within Unreal called line trace single by channel. To call that, we need to fill out a relatively big parameter list, 5 parameters. And so we need to make these variables so we can pass them into the function. The first two that we need to make, we don't have to set anything up with. We just pass in a variable so that the function here can return this data to us. So we pass in a hit result, we pass in a collision params, and it returns the data for us to use. We do have to have variables though. We can't just capture them. We do have to pass something into it. So we're going to make an f hit result. Hit result is going to be used to determine what type of object we hit. So if we hit the ground below us, we can tell, oh, it's a static mesh object of the ground. We don't have to do anything with it. We can't interact with it. But if we hit that cube that you saw earlier in the demo, then you can say, oh, this is an interactable actor, so we can do this logic with it. This f collision query params is the collision query parameters, and I called it collision rules. It's basically going to determine what can we collide with, what can we not collide with, so if there's certain objects you want to go through. Again, it's not super important for now. In fact, we're not even going to use it today, but this line trace single by channel function that we do need requires you to put one in here. And so we're making it so we can pass it along, even though we're not using it today. The last thing we need is the start and end location, so where we want the ray to begin and where we want the ray to end. The beginning is easy because it's the camera. We're starting from the camera, what the player sees. So we can set this f vector start location to be equal to the camera component that we made earlier in the episode, and then get component location. The end is going to be, we need to know the direction and how far to go, and add that to the start location, and that'll be our end location. So we make another f vector called end location, and it's equal to the camera's get forward vector. That's how we know the direction to apply this distance. And we're going to multiply it by the interact distance variable that we set up earlier in the episode. Then just plus start location. We do want to make sure that we multiply the distance by the forward vector. Do that operation, then add the start location. This will happen automatically already because of order of operations. Here you can see we have an if statement where we're calling this function. So this function is actually able to be called through getWorld. So we can do getWorld, line trace single by channel, and then we have to pass in these parameters. So the first we need is the hit result. Then we need the start location, the end location. This is for the visibility of the line that is drawn. I set it to a default of ECC visibility, which is collision channel visibility. And then the collision rules, which again, I haven't done anything with. It's going to return the collision rules back to us. But we don't have to set anything up for it, so just pass that in as the last parameter there. Now, assuming this line trace succeeds, then it is going to bring us in here into this if statement, and then we can gather information about it. The main thing we want to see is if we have hit a blocking object. If we have, we know that we are close enough to something that we collided with it with the raycast. If it's not a blocking hit, it could be an overlap hit, or we could be firing straight up into the air where we're not hitting anything at all. But we want to specifically know if we've had a blocking hit. If we have a blocking hit, we can then do logic on that hit with the actor that was retrieved. So at this point, we need to set up a class to do more logic on this, but you could test with a log or with a breakpoint to see if you're hitting anything. Let's stay where we are and now make a new C++ class for our interactable actors. I know we already have a few like weapons and things like that. These are actually going to be their own separate class, because if we have a door or pick up equipment that we can have in the world, we don't want to necessarily use that as the same as like interacting with a weapon. They are different because there's different things you can do with them. So I'd recommend having a fully unique class for this. So I'm going to go into my engine. I'm going to go to C++ classes and hit add new C++ class. When I do this, I have a bunch of options. I do want it to be an actor because it can encompass a lot of different objects in the world. I'm going to call it interactable actor and create class. I've already done this. I called it base interactable actor. So I can't create class here, but you can name it whatever you want. Hit create class. Once you get out of all this, Visual Studio should open, but if it doesn't, you can go open it up yourself and click on source and then the name of your project, and you should be able to see them here. You're going to open up base interactable actor.cpp and .h. I've got these guys here. For me, I haven't actually done anything in here yet, not in the CPP. I did add one function that we can call in the .h. So your CPP should look very similar to this. Could be a little bit different based on the version and a few other things, but it should be the same. I haven't added anything in here. In the .h, it should be this pretty much the same as well. The only difference here is that I'm going to add this function. As I said, I've actually added a blueprint implementable event called display interact prompt, because how it's actually going to be used is for us to spawn a widget that's giving us details about the object and the interaction as a whole. But for now, we can use it to just print a string to the screen to know that it is working. So go ahead and add a new function in here and make sure it is a ufunction blueprint implementable event so we can fill out the logic for it in the blueprint. I've given it a category of interact. I've called it void display interact prompt, and I've passed along a constant f-string reference actor name. This is a constant value. I can't change it when it comes in this function. An f-string reference is just saying that we're passing along a reference. We're not making a copy of the string. So essentially just think of this as an f-string, and then this is the name of your string. The reason we're doing it so specific like this is because we're going to need to do that when we call this function. You can't just pass an f-string to a blueprint implementable event, so we had to make it set up like this, but it is actually good practice because it's more efficient than just passing in a copy of an f-string. And again, constant just means that we won't be changing it. So now if we go back into our FPS tutorial character, you can try and use your interactable class, but it's not going to work. We have to include it. So if we go up to the top of our CPP file here, we can just do include right at the bottom, include our new class .h. So once you've done this, we can now access this class from the FPS store character.cpp. So now within our if hit result.be blocking hit, we can determine if the hit was then an interactable actor. And if it was, we can do further logic from there. Because most of our hits we're going to ignore. They might not be relevant. So now we want to make a new variable, if auto interactable actor. And we want to cast the hit result.getActor to our new class here. So cast a base interactable actor. And what we're casting is the hit result.getActor. Like that. So we're going to take the actor that we hit with the ray trace and cast it to this type. If it succeeds, we know we are a type of interactable actor. Thus, the player can interact with this object that we hit. So at this point, we can now do logic on the interactable actor. And what we want to do is call display interact prompt. And I'm passing it the name. You could get the name plenty of other ways. You could store a name on this actor. You don't have to pass the name of the actor into its own function. This is just how I've decided to do it. But this display interact prompt takes in a name, so we can use our interactable actor. And then we can get name on that, pass that in. Essentially, since we know that we are hitting an interactable actor, we now want to display what we would display for any objects within our range that we can interact with that we're looking at. Back in the editor now, we need a way to check if we're hitting this, so it needs to have something that it can hit, such as a mesh. A simple way of doing this is going into where your blueprints are. I made a new folder called Interactables, and I've added a new blueprint class that is a child of the new code class we just made. So you can search in all classes here for your base interactable actor. You can select your base interactable actor and hit select. Once you do that, it will make a new blueprint class with that as the parent, and you can call it whatever you want. I made mine base interactable BP. Once you go into there, you have your default scene root here. I just added a static mesh to it. And on the static mesh, I've added a cube as the static mesh. This is from the starter content, so you can use whatever you want. And nothing else here has to be changed. All the default values on it are fine. This cube will have the ability to block that raycast, so it will show up in the results, the hit result in the code when we look at it. Quick note, you can also get rid of the default scene root as you don't need it. You could drag the static mesh on top of it to make it the default component, just to clean things up a little bit. And now at this point, we have to fill out the logic that we want to occur when we look at this object. So we can capture that event that we made by typing in the name here. So it's display interact prompt. And this event is the one that we made in the .h of the base interactable actor. So we're capturing this event, and now we have to determine what we want to do when this event is fired. And so in this episode, since this is already a long one, I'm just going to print a string. But this could be very, very long. We could do a lot of logic in this function. What I'm doing is I'm taking the actor name that was passed in, and I'm calling string append, passing in A as a default string of text, which is the character is able to interact with. And then for the actor name, or use that for B. That's what I've done here. And so it'll say the character is able to interact with, and then the name of the actor that we collided with. Put a little space after A if you want. That way they're not right up against each other. And then I've just called print string and passed in the return from the append into this. So that is the text that you will see when we select it in the level, when we look at it in the level, that is flooding the screen when we're looking at it. The last thing you need to do is add this to the level, so make sure you drag in a base interactable BP, at least one of them, somewhere in the level. You can literally just put it wherever, doesn't matter. I position mine here. Now if I walk over to it, you'll see if I walk over to other things, nothing is printing to the screen. But as soon as I look at this object, then the character is able to interact with this base interactable BP. If I go too far, you can see I can still interact with it from here, so it's a little far. If I go too far, I won't be able to interact with it, even though I'm looking at it. So I have huge arms right now. Should definitely be decreased. But I can only interact with it when I'm looking at it. So if I'm not looking at it, it goes away. So from here, I would just change our interaction distance, and you can test getting the proper result by clicking on your base character BP, searching for interact distance. You see I have 1000 here. I can change it to 500. And then you see I can no longer interact with it from back here. I have to move closer to be able to interact with it. And this is a lot more reasonable, although it's still probably pretty far. So I can come back over here and change this to 200. Come back in here. You see I can't interact with it from here. So that's probably pretty far. And maybe this is a little too short. I don't know. But there we go. You can see how I can change the value by testing it in the details panel over here. Now, note that this won't save. So when I close this, that base character BP is going to have an interact distance of 1000 again. To fix it, you have to actually go into the code like all your other variables and set it to a different value. So I could set it to 200 as an example. I'll make it 300 because I think 200 was a little short. But that's a quick way to test it without closing, relaunching every single time. So anyway, guys, that's how you can set up a basic interaction system by looking at an object as opposed to just being overlapping with it or being within a proximity distance of it. So it can be really useful. We're going to do a lot with it in the future. I hope you enjoyed it, and I hope this helped you make your interaction system, set it up, and I hope you can see some use in it and what you're going to be using it for. If it did, please subscribe. It does a lot for me, and I really appreciate it. I want to give another huge shout out to my YouTube membership and Patreon members and supporters. Thank you guys for the love and support once again. I appreciate all you do. If you get any issues with this tutorial or any of my tutorials, feel free to join the Discord for free support. I'd be happy to help you and get you sorted. And that's all I got. So thank you so much for watching, guys. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.